So following on from the previous video, these two examples are a little bit trickier, solving equations with exponents. So this example asks us to solve the simultaneous equations to get the values of A and B. Okay, so simultaneous equations, we're obviously going to be looking for two separate equations that we can then use either elimination or substitution to solve to find A and B. Okay. So if we start by looking at this one and see how can we simplify the information that we've got here. So we've got x to the power of a to the power of 2. So we know when we've got brackets here, this means x to the power of a times itself. So we can just multiply this 2 and this a together, which gives us x to the power of 2a. Okay, and again here, 4 times 2b gives us x to the power of 8b. Okay, so we've got the same base here, 2a therefore must be equal to 8b. So we can write that out as an equation, 2a equals 8b. And I want to put it into a sort of linear equation form, so I can use elimination potentially to solve it. So I'm going to rearrange it so it's equal to 0. So 8b take away 2a is equal to 0. Okay, and I'll number that my first equation here. Okay, so I'm going to go over to this one now. We know that root x is the same as x to the power of a half. So we've got x to the power of a half to the power of a. We multiply powers together, which is going to give us x to the power of a over 2. And on this side, we've got x to the power of 3 divided by x to the power of 6. So using index laws, we're going to subtract the powers. So 3 take away, sorry, not 6, b. 3 take away b is x to the power of 3 minus b. Okay, can't read my own handwriting there. It's definitely a b, not a 6. Okay, so again, got the same base. So our powers are going to be equal to each other. A divided by 2 is equal to 3 minus b. I'm going to rearrange it into form where I have a linear equation equal to 0. So I'm going to move my 3 minus, actually I'm just going to move my minus b over to this side, which gives me a over 2 plus b equals 3. Okay, I want to get rid of this denominator of 2 here, this fraction. So I'm going to multiply the whole equation by 2. I need to then multiply every term within the equation by 2. So a divided by 2 multiplied by 2 is a plus 2b equals 6. Okay, so I've now got a second linear equation that I can use to solve. So I'm going to number that one equation number 2. Okay, so I'm going to use elimination to solve these equations. At the moment, I've got 8b minus 2a and a plus 2b. So I'm going to need to either make my a's or my b's the same. So I've got minus 2a here. So I'm going to multiply this whole equation by 2 so that I have a 2a here. First of all, I'm going to rearrange it so that I have my b's in the same position. So obviously that's exactly the same as that. Okay, and then I'm going to times by 2 to get 2a, which will give me 4b plus 2a is equal to 12. Okay, and that's equation number 2. So now I've got minus 2a and plus 2a, I can use elimination. So if we put 8b minus 2a equals 0 on top, 4b, that's equation number 1, number 2, plus 2a equals 12 on the bottom. I've got two different signs here, so I'm going to add the equations together. Same signs, we would subtract, different signs we're going to add. Okay, 8b plus 4b is 12b, minus 2a plus 2a is obviously 0, and 0 plus 12 is 12. So I know that b is equal to 1. 12 divided by 12 is 1. And then I just need to substitute the value of 1 back into the equation using either one of my simultaneous equations. So if I use this one, 8 times 1, take away 2a equals 0. 8 take away 2a equals 0, and hopefully you can all see 8 take away 8 is 0, therefore 2 times 4 is 8. A must be equal to 4. Okay. So if you want to be 100% sure and check your answer, then it's always worth substituting these two values into the other equation just to check.